On the basis of water circulation and stratification, estuaries can be classified into three broad categories: highly stratified estuary or salt wet estuary. The water flow of the water is strongly dominant over tidal action. Freshwater tend to overflow the heavier salt water, forming a wet. This type of estuaries is characterized by sharp change in salinity from top to bottom. Example: Mississippi, Mississippi River Estuary, United States. The Bhalar Estuary, India. Schematic representation of water circulation, salinity, and velocity gradient in salt wet estuary. Longitudinal profile to show water circulation. The horizontal arrow show the residual flow seaward at the surface due to mixing, and river flow and landward at the bottom due to vertical mixing across the river water. Seawater interface. The lines represent the salinity gradient, velocity, depth profile to show the residual flows. The partially mixed or moderately stratified estuary, where freshwater and tidal inflows are nearly equal. The dominant mixing agent is turbulence and salinity profile is less steep. The salinity structure is very different from highly stratified estuary because of the efficient mixing of salt and fresh water. The surface salinity increase steadily down the estuary with undiluted fresh water now occurring only near the head of the estuary. Example: Chesapeake Bay Estuary, United States; James River Estuary, United States; Mersey and Southam, Southampton Water Estuary, England. Schematic representation of water circulation, salinity, and velocity gradient in a partially mixed estuary. A longitudinal section showing water circulation and salinity gradient. The dashed sub-horizontal line is the depth at which is no horizontal residual flow either seaward or landward. B. Salinity depth profile along the dashed, dashed vertical line in A, showing the poorly defined hollow line. Salinity difference between surface and bottom values along the estuary from river to sea. Velocity depth profile along the dashed line in showing mark upstream residual flow of seawater at the bed. The completely mixed or well mixed or vertically homogeneous estuary. The tidal action is strongly dominant. The water tend to well mixed from top to bottom and the salinity relatively high. Example: 7 Severn Estuary, Firth of Forth, lower reaches of United States. On the basis of water balance, estuaries are three types. Positive estuary. Positive estuaries are those in which freshwater addition from river discharge, rain and ice melting exceed freshwater losses from evaporation to freezing and establishing a longitudinal density gradient. In positive estuaries, the longitudinal density gradient drives a net volume overflow to the ocean, as denoted by stronger surface outflow than near bottom inflow. In response to the supplementary freshwater, the circulation indeed by the volume of the freshwater added to the basin is widely known as estuarine or gravitational circulation. Majority estuaries are positive estuary. Inverse or negative estuary. Inverse estuaries are typically found in arid region where freshwater losses from evaporation exceed freshwater addition from precipitation. There is no or scant river discharge into those symptoms. They are called inverse or negative because the longitudinal density gradient has the opposite sign to the positive estuaries. Water density increase landward. Inverse estuaries exhibit net volume inflows associated with stronger surface inflow than near bottom outflow. Water losses related to inverse estuaries make their flushing more sluggish than positive estuaries because of their relatively sluggish flushing. Negative estuaries are likely more prone to water quality problem than positive estuaries. Low inflow estuaries. Low inflow estuaries also occur in region of high evaporation rate but with a small on the other of a few MP M3 m to the power 3 per second influence from river discharge. During the dry and hot season, evaporation process may cause salinity maximum zone, sometimes referred to as salt plug. Walangshi 1986. Within these low inflow estuaries, seaward of the salinity is maximum. The water density decreases as in an inverse estuary. Landward of the salinity maximum, the water density decrease as the positive estuary. Therefore, the zone of maximum salinity act as barrier that preclude the seaward flushing the riverine water and the landward intrusion of ocean water. Because of their weak flushing in the region landward of the salinity maximum, low inflow estuaries are also prone to water quality problem. Importance of estuaries. Estuaries provide us with suite of resources, benefit and services. Some of these can be measured in money while other cannot. Estuaries provide places for recreational activities, scientific study and aesthetic enjoyment. Estuaries are an irreplaceable natural resources that must be managed carefully for the mutual benefit of all who enjoy and depend on them. However, the importance of estuaries are as in the next page. Ecological or environmental value. Estuaries are one of the most productive ecosystem on earth. They are the place where basic things needed for life are made available to wide varieties of organisms. They maintain water quality through natural filtration as microbe breakdown, organic matter and sediment bind pollutant. They store and recycle nutrient trap sediment from natural buffer between the land and the ocean by absorbing floodwater and storm surge and trap and detoxify harmful pollutant. The water flowing to the ocean carries sediment, organic, inorganic nutrient and pollutant. Much of the sediment and pollutant are filtered out when they flow through wetlands, swamp and salt marshes. Runoff from the land is clean before it enters a lake or ocean, and the effect of flooding and water level changes are lessened. This creates cleaner and clearer water, which benefit both people and marine. Estuaries plant like mangroves, seagrasses, and reed also act as natural buffer between the land of ocean. Because this can absorb tide and storm surges, providing peaceful and stable habitat for wildlife. This natural buffer help to prevent erosion and stabilize the coast. They help to maintain biodiversity by providing diverse range of unique habitat that are critical for the survival of many species. They are used as nesting, breeding, and feeding site for many species. Many estuarine plants, such as mangrove, seagrasses, support estuaries specific habitat. Thousands of species of bird, mammals, fish, and other wildlife depend on estuarine habitat as places to live, feed, and reproduce. Migratory birds use estuaries to rest and gain food during their journey. Many fish and shellfish species, including most commercially and recreationally important species, depend on the sheltered water of estuaries as home to spawn and for their offspring or juvenile to grow and live. Therefore, they serve as breeding and nursery ground for many important animals that live in deeper water. They are also called nurseries of the sea. Economic value. They are tourist attraction. Million of people visit nations estuaries each year to boat, swim, birdwatch and fish. They are used for transport and industry. They have ecological importance to commercial fisheries. They maintain water quality which benefit both people and marine life. They offer natural buffer between the land and ocean by absorbing flood water and storm surges. They reduce water erosion by slowing the movement of water. This protect building and other structure from potential storm damage. They help maintain biodiversity by providing a diverse range of unique habitat that are critical for survival of many species. Many species of commercially important fish and shellfish use estuaries as nurseries to spawn and allow juvenile to grow. Cultural value. People use estuaries for recreation, scientific knowledge, education, aesthetic, and traditional practices. Boating, fishing, swimming, surfing, and birdwatching are just a few numerous recreational activities that people enjoy in estuaries. Unique estuaries habitat make them valuable laboratories for scientists and students. A wide range of problems in biology, geology, chemistry, physics, and sociology are studied in and around estuaries. Estuaries also provide a great deal of aesthetic enjoyment for the people who live, work, and use them for recreation. Estuaries provide us with numerous resources upon which a money value cannot easily be placed. They offer benefit and services which greatly improve our lifestyle. Estuaries are an irreplaceable natural resource that must be managed carefully for the mutual benefit of all who enjoy and depend on them. Biota of estuaries. Biota is the animal and plant life characterized by a given region. Biota is animal and plant life a particular region, habitat or geological period. In estuaries, plant and different group are present, including phytoplankton, benthic, diatom, bacteria, fungi, and larger microphyte. Though estuaries are rich in their nutrient, phytoplanktonic organisms are not abundant. This is due to reduction in light penetration as a result of turbidity. Most of them are marine origin and freshwater plankton is poorly represented. The important estuarine phytoplanktonic organisms are diatom and dinoflagellate. The diatom are Skeletonema costatum, Paralia sulcata, etc. Keratium purga and Ceratum beckeros are dinoflagellate of the estuaries. The benthic diatom are bottom dwelling.